Okay, for our last section in chapter 6, we are going to be doing product to sum and sum to product identities. We have 3 product to sum formulas, identities that we're going to work with, and we have 4 sum to product identities. Now, product to sum means what it says. We are starting with a product where we're multiplying 2 trig functions together, and we're going to end up with a sum that we are adding together. And then when we do the next page, the sum to product, we're turning that around. One more time, remember you do not have to memorize all of these identities for the exam. They will be provided to you as one of the questions so that you can go back and look at them during the exam as necessary. You do have to be familiar with them and know how they work and how to use them. So the proofs of these formulas are found in the textbook, and that is the statement is going to give to you. We are not going to derive them ourselves. I promised you we weren't going to derive them all. This book does derive more than I remembered from going through it in previous semesters, but that's okay. We did a lot of good work with that. These we're just going to copy down. Now, all of these start with a factor of 1/2 being multiplied in. All 3 of these start with 1/2 times the quantity. And inside brackets, for sine alpha, sine beta, this product gives us cosine of the difference of the angles minus cosine of the sum of the angles. For cosine alpha, cosine beta, we start with that factor of 1/2. And then what is inside follows just like the last one, cosine of the difference plus, this time, cosine of the sum. And for sine alpha, cosine beta, we have sine of the sum plus sine of the difference. One last time. Do not have to memorize all of this. You will have it to look back on to make sure you get all the little pieces correct. What's important is that you know how to use them. I'm given sine of 3 theta times sine of 7 theta. So this is sine alpha, sine beta, where alpha is 3 theta and beta is 7 theta. I'm going to express that as this first identity. So I have 1/2 times cosine of the difference, 3 theta minus 7 theta, minus cosine of the sum. Well, simplifying, that gives me 1/2 of cosine of negative 4 theta minus cosine of 10 theta. And then I remember that cosine is an even identity, or an even function, sorry. So I have 1/2 cosine of 4 theta minus cosine of 10 theta. All right. Let's look at the next one. Cosine theta, cosine 5 theta. I'm multiplying these. This is a product. We want to rewrite it, express it as a sum. We're using our second identity here where we have alpha and beta. This is alpha, this is beta. So that gives me 1/2 times the quantity, cosine of the difference, so theta minus 5 theta, plus cosine of the sum. Simplifying, I get 1/2 of cosine negative 4 theta plus cosine of 6 theta. And then finally, cosine is an even function, so cosine of 4 theta plus cosine of 6 theta. Notice I don't go ahead and combine those. The arguments are different. Those are not like terms. So that is where I stop. Our last one on this page, sine alpha times cosine beta, is that third identity, product to sum identity that I was introduced to at the top. I have sine of the sum plus sine of the difference. So that gives me 1/2 of sine of 9 theta plus sine of -5 theta. And sine is an odd function. So that needs to be simplified to be sine of 1/2 sine of 9 theta minus sine of 5 theta. Here we remember not to leave that negative in our argument. When you're working through any written assignments for me, I do want to see steps. I want to see things neatly organized, neatly arranged, and I want to see work so that I know you didn't just copy an answer down from someone. Okay, sum to product formulas. Now I'm starting by adding or subtracting. I end up with a product. You will see another repeated pattern here. This is a misprint. We have cosine alpha plus cosine beta here. That's a sum. This needs to be a difference. It needs to be cosine alpha minus cosine beta. All right, you can copy these down from your sheet, or you can copy them down here with me. Alpha plus beta over 2, and then we have alpha minus beta over 2. So 2 sine of this, cosine of that. Sine of the sum, cosine of the difference. When we do sine alpha minus sine beta, we have 2 sine of the difference, cosine of the sum. So we switched those arguments from the original, from the previous. Cosine alpha plus cosine beta, we have 2 cosine, half the sum, cosine, half the difference. And then finally, cosine alpha minus cosine beta is a -2 times the sine of half the sum times the sine of half the difference. All right, let's do a couple of these. Sine of 4 theta minus sine of 6 theta. Well, sine minus sine is our second sum to product that we use, sine minus sine, where in this case 4 theta is the first angle, 6 theta is the second. So here's what that needs to look like. 2 times the sine of the difference, 4 theta minus 6 theta over 2, times the cosine of the sum, 4 theta plus 6 theta over 2. When I start simplifying that, I have 2 times the sine of -2 theta over 2 times the cosine of 10 theta over 2, which is 2 times the sine of -theta times the cosine of 5 theta, and sine is an odd function. So simplified all the way, I pull that negative out front. All right, this was a short and sweet section. We've got one more to do where we are adding the cosine functions of 2 different angles. That is our third in the list here. So that I have 2 times the cosine of the sum, half, times the cosine of the difference, half. So that gives me 2 cosine of 10 theta half, cosine of -6 theta half, which is 2 cosine of 5 theta, cosine of -3 theta. Cosine is even, so simplified completely. There we go.